Hi, welcome back to Engineering Drawing. I'm your Dr. Vasu. Hope you are enjoying the previous videos on engineering drawing. If you want to learn this and many more interesting topics, please do subscribe this channel. If you like this video, please hit the like button. That will keep me motivated to create more such videos in the future. Now let's jump right into the topic. Let's see the diagonal scales. So here, so far in the previous videos, we have seen plane scales. In the plane scales, we have only two units, meters and decimeters, or kilometers, hectometers, like that. Only two units are possible. Suppose if we want to have third unit also, next unit, kilometers, hectometers, and decameters, or meters, decimeters, and centimeters, like that. So how to get it? Here, let us see the principle behind this diagonal scales. So I take a line AB of some length, okay, and I draw a perpendicular to this and call it as BC, okay. Now, join AC here like this, and I have taken a midpoint here on BC. This point is the midpoint of BC. Through this point, we draw a line here and mark this as a DE, a horizontal line that is parallel to AB, and this is DE. Now, if you observe, this ABC and DEF are two triangles, and we call them as similar triangles. Okay. Now, if you see the property of this similar triangles, this AB by BC is equal to DE by EC. Okay. Now, this DE is equal to, from this formula, we take this EC by BC into AB. Okay. So, from this equation, we get it. Now, let us suppose give the values to this. EC is actually half of BC, right? So if you substitute this value as 1 and BC as 2, you get half into AB. So here we got the length of DE as half of AB when you have taken this midpoint of BC. Okay, this is the basic principle used behind in using the diagonal scales. Let's apply this further. Okay, we take one point here that is 1/10 of BC. This is at a distance of, suppose this is 10 units. This point 1 is 1 unit from C. Suppose this is 10 centimeters. This is 1 centimeter here. Now, draw a horizontal line and mark it as 1 dash. Now again, this ABC and 1 dash 1C, these two are called similar triangles. Applying the same principle like this one, you get AB by BC is equal to 1 dash 1 divided by 1C. That is, your 1 dash 1 will be 1C by BC into AB from this equation. Now, substituting, because we have assumed that this is 1 unit, 1 centimeter, right? This is 1 centimeter, BC is 10 centimeters or 10 units. So, this substituting these values, you get 1 by 10 into AB. So, what is 1 dash 1? 1 dash 1 is nothing but 1/10 of or 0.1 of AB. That means when you have taken a point here at a distance of 1/10 of BC, you get in this AB, this 1 dash 1 will be 0.1. Okay, 1/10 of it. Right. This is the same principle. We are going to use it here to find out in AB, I want to get, suppose 1/10. That means you have to take 1/10 of distance on BC here, like that. So let us apply this and see how it is used. So Suppose if I take instead of 1 centimeter, if I take 2 units, right? Passing through 2, if you draw a line here, right? Mark this as 2 dash 2, right? How much will be the length of this one? In AB, it is 2 tens, 2 by 10, 3 by 10, 4 by 10, 5 by 10. It is half. 5 by 10 means half. This is what we got here. DE. DE is nothing but 5 by 5 by 10. So 5 by 10 here. Like this point, this distance will be 6 by 10 of AB. Or this is 8 by 10 of AB, 9 by 10 of AB, like that. So let's apply this to a problem. We take a problem here, construct a diagonal scale, RF is given. We want to show meters, decimeters, and centimeters to measure up to 6 meters, right? Maximum length. So take the RF value, maximum length, calculate length of the scale, the RF into maximum length, you get 20 centimeters. Convert it to centimeters here, we get 20 centimeters. Draw a rectangle of this length 20 mm, 20 centimeters. And now let us divide this into 6 parts because this is 6 meters length. This is representing 6 meters. So divide this into 6 equal parts and name them here starting from first division 0, 1, 2, 3, 4 like this. Each unit, each division represents meter. This is 1 meter again. So here divide this into 10 equal parts because 1 meter is equal to 10 decimeters. So divide this into 10 equal parts and mark them as 1, 2, 3, 4, 5 in the left sides like this. And because of a space problem, just I have taken 5 and 10. Each one indicates decimeter. Okay. Now, this is a plain scale so far. But still now I want the next unit to decimeter, that is centimeters. Centimeter means this is 1 decimeter. Suppose I want to have 1/10 of this. So if I am going to divide this into 10 parts and 10 lines here, we can't see anything. Everything just appears to be dark and we can't distinguish. So for this, we use the diagonal scale principle and we do this like this. We have taken, right? We have taken the, forget about this part, and we have taken a rectangle like this. We have taken a vertical line, and this vertical line similar to our BC in the previous figure. So we have marked this 1, 2, 3, 4 up to 10 because 1 decimeter is equal to 10 centimeters. So take 10 divisions on this, and now I'm going to divide this the same as the earlier one, right? Here we have A, B, and C in the earlier figure. Similarly, we have marked this 1, 2, 3, 4 points like this, drawn horizontal lines. And we know that this distance is nothing but this distance, right? Only thing is we have drawn a line, inclined line, diagonal, we call it as a diagonal. This first division here is joined with the 0. Like that, second one is joined with the first one here. Like that, when you see this triangle, right? This is suppose, this is 1 decimeter. We know that this distance is 1 decimeter. So this is also 1 decimeter. Now, through point 1, we have drawn a horizontal line. And if you see this distance between this inclined line and this vertical line, this distance gives 1/10 of this length. This length is nothing but 1 decimeter. So 1 decimeter divided by 10 means 1 centimeter. This length actually gives 1 centimeter. That's how we get centimeters here, right? We are able to measure 1 centimeter also. Now, here, this is the diagonal scale, okay? And actually, we have extended this one to mark the lengths on this, okay? So the thing is, here the first point is the first division is joined with the 0, second with 1, 3, third with the second, like this. Okay, last one with the ninth one. Now, suppose if I want a 0.5 decimeter or 5 centimeters, here you take 0.5 here, 0.5, and through 5 you have in this line, and this distance here actually indicates 5 centimeters or 0.5 decimeter, like that. Now we will see, we will show this length on this. 3 meters, the meters are here, 3 meters, we draw a line here, 3 meters passing through this, 5 decimeters, right? 5 decimeters, from 0 up to here it is 5 decimeters. I want 3 centimeters also. So from this point, we follow this line up to third division, third point, right? This is the fifth one, that is giving 5 decimeters. And from this, if you follow up to third one here, this point gives from here, if you draw a line, this point up to here, right? 3 centimeters. This is if you draw a vertical line and mark it, that small distance is 3 centimeters. So we have drawn extension lines and show the dimensioning line. This is 3.53 or 3 meters, 5 decimeters and 3 centimeters. Okay. So this is the diagonal scale we will be applying. The principle is applied like this. Okay. Next, suppose a drawing is prepared in such a scale that an acute angle, actual distance of 4.5 meters is represented by a line of 30 mm long. Okay, you have to find out the RF. So let's take the RF here. How the length of the line here divided by the actual distance 4.5 meters. Convert them into same millimeters both sides. The numerator and denominator 1000 mm. So calculate RF 1 by 150. Maximum length here is actually the length of the scale is 10 meters is enough. That is asked. But here for the sake of convenience, calculation sake, we have taken 12 meters just to avoid decimal places. So 12 meters is taken for calculation convenience. And now length of the scale is equal to RF into maximum length. So 12 meters. Meters into 100 centimeters. This gives 8 centimeters. Now draw a line of 8 centimeters here and now divide this into how many parts? We have divided this into 6 parts, right? 1, 2, 3, 4, 5, 6. Okay. And each one indicates 2 meters, right? Each division indicates 2 meters. Okay. Now, actually, you can actually divide this into 12 parts also, but this is convenient a bit. Okay. Now, you have divide this into 2 parts. That means each one gives 1 meter. Okay. This gives 1 meter, 2 meters. So, on the right side as well as left side, you have meters. Now, we have 1 meter here. Okay. Now, let us draw the diagonal scale by taking a vertical line here and some known length is taken. Some known length. Some length. You take, say, 5 mm or 6 mm. It's your convenient and the amount of space available here. So, we have marked 10 divisions, 10 points. Why? Because 1 meter is equal to 10 decimeters. Next unit is decimeters. 1 meter is equal to 10 decimeters. So divide this into, take 10 points here on this vertical line, right? Now draw horizontal line. And from here, suppose if you take the corresponding point 1 here is this. 1 is here. So join this point with the 0. First point is joined with the 0. Second one with the 1. That means here this length is actually 1 meter. This is equal to this. And this is 1 meter. And now I want 1/10 of this 1 meter, right? Here it is. Through 1, we have this distance. This gives 1 meter length, right? 1 decimeter. Okay. 1 decimeter is obtained here. Likewise, 2 decimeters, 3 decimeters, 10 decimeters, or 1 meter. Okay. Now let us show mark 4.5 meters, right? 4, you can have 4 here, right? Through 4 meters, 0.5 meters, 0.5, right? Not even 1, 0.5. That means from 0, I go to 5th division here, 5th point. So if you draw a line here through this, you get this distance as 4.5 meters. Okay. Now, let us have 7.8 meters. 7, you can take, so I have taken 6 here because we don't have 7. If you mark 1 division here, you can take 7, but here I have taken 6 because it is readily available. So 6 meters are available here. 1.8 is to be marked now. 1 here, I have 1 meter. From here, I go to 8th point. From here, I go to 8th point. So this gives, through this, if you draw a line here through 8, you get 0.8 meters, right? This distance, what is that? Up to here, if you draw a vertical line, this distance is from up to this vertical line, it is 1 meter. From this vertical line, this is 0.8 meters. So from here, it is 1.8 meters. So draw this extension line and join these two and draw a dimension line, show the length, 7.8 meters. So that's how you get the required lengths. Up to 12 meters you can measure. Only 10 meters is asked, but you can measure up to 12 meters. Right. Let us see one more problem. Here you have British units, yards, feet, and inches. It will be interesting problem. So let us see. RF is given. RF is 1/32, right? And you have to show 3 units. Yards, next unit, next smaller unit, feet, next smaller unit, inches. Now let us see. Maximum length 4 yards is given. 4 yards. And length of the scale, RF into maximum length. Here you have to see this is a RF maximum length into yards into 1 yard is equal to 3 feet. So into 3, 1 foot is equal to 12 inches. So into 12, that is inches. If you calculate, you get 4.5 inches. So we get a line of 4.5 inches. Draw a 4.5 inches line and mark a rectangle here like this. And now divide this into how many parts? Yards, 4 yards. This is representing 4 yards. So we take 4 yards here. Divide into 4 parts. Name them as 0, 1, 2, 3. Each one, this division indicates yards, 1 yard. Now, in the left side also, this length indicates 1 yard. So 1 yard is equal to 3 feet. Divide this into 3 parts. Divide this 1 yard into 3 parts. Name, mark it 1, 2, 3. This is 1 foot, right? This like distance is 1 foot here. Mark this distance, and these are feet, 3 feet. Now I want inches. 1 foot is equal to 12 inches. So draw a vertical line and mark 12 points here at known distances. You take a vertical line like this, and now here on this, mark 12 points, maybe each one 5 mm distance or 6 mm, it depends. So we have marked 12 points here on this, right? All the 12 points are marked. Through these points, draw horizontal lines. Draw horizontal lines. So 1, 2, 3 like this. Now corresponding point 1 is here, 2 is here. Join this point 1 with 0, right? Join 1 with 0, second with 1, like that. Diagonally, we'll be drawing the lines. Now, this is how much? 1 foot. This is 1 foot. This is also 1 foot. Now, coming to this, 12 parts are taken. I want, if you see this line passing through point 1, right? Here we have a small length. How much is this? 1/12 of this length. Because we have taken 12 divisions, this length is 1/12 of this length. 1/12 of 1 foot is equal to 1 inch. That means we are able to measure 1 inch here, right? 2 inches, 3 inches, 4 inches, like that. So we are able to measure 1 inch as well as 1 foot and yard also. Now let us show some dimension. 2 yards, say take 2, at 2 draw a line. 2 feet, we have 1, 2, 2 feet, right? Vertically you have to draw a line like this actually. But assume that here we have a vertical line. And we have to, from this vertical line, you need to mark 5 inches. That means 5th point. So this vertical line already we are imagining from here to here it is 5 inches. So 2 feet, 5 inches. Draw a vertical line here through this point. You get 2 yards, 2 feet and 5 inches length. So that's how you can draw a diagonal scale with the metric units or British units like this. Okay. Hope you understood this topic on diagonal scales, right? And if you have any queries or any suggestions to make, please do comment below. And thank you very much.